Hello students, in today's class we are going to study the electronic configuration and we will be studying different kinds of electronic configuration for different kinds of orbitals. So over here the first thing we are going to study is the electron filling pattern. Now every orbital, whether it is s orbital, p orbital, d orbital or s orbital, will have electrons present in it. And these electrons come under the electron filling pattern. Electrons fill up energy levels in a predictable manner. The electron filling pattern is 1s2, 2s2, 2p6. So over here they have just given us the shells. So if you can see, I have the S. After that I have P. After that I have D. And after that I have F. So it is something like 1s, 2s, 2p. I'm simply copying this part over here. 3s, 3p. After 3s, 3p I have 4s. And then I have a 3D. Why? Because first we have S, then we have P, and eventually we have D. That means first the electrons will fill in the 1s orbital. After that they will go to the 2s orbital. Then they will go to the 2p orbital. After that they'll go to the 3s orbital. Then they'll go to the 3p orbital. After 3p they'll go to 4s. And once 4s is completely filled, they will go to 3D again. So this is how it goes. Then again after 4s you have 4p. And after 4p what will get filled? The 5s. Once the 5s is completely filled, it will go again to 4d. After 4p it goes to 5s. After 5s it goes to 4d. And then you have 5p. Once 5p gets filled, where it will go? It will go to 6s. And once 6s gets filled, it will go to 5d. So that is how it goes. Also remember, the s orbital can hold maximum of 2 electrons. The p can hold maximum of 6 electrons. D can hold maximum of 10 electrons. And the f orbital can hold maximum of 14 electrons. So if we start filling, let me just change the color and try filling in for you. If we start filling, it will go something like 1s2, 2s2, 2p6. Why? Because p has the maximum of 6 electrons. Then you have 3s2, 3p6. After that you go to 4s2, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2, 5d10, and after that 6p6, and so on. The S, P, D, and F are so on are the names given to the orbitals that can hold the electrons. Over here you have the orbital shapes of S. In the S it has the nucleus in the middle. The orbital shape is spherical in nature, which has electrons, and I can just make the 3 axes X, Y, and Z. For the P, as you can see, the nucleus is in the middle and it is a dumbbell-shaped orbital. That means the electron will be moving on in the dumbbell shape. Again, it is shown in all the 3 axes X, Y, and Z. The nucleus in the middle and the electron revolving around. If you can see D, over here if you can see D is tough to show it in a 2D format. We thankfully have it in the 3D version. The nucleus is there in the middle. And then if you can see, this is one loop. Behind that we had the second loop. In front we have again the third loop. And the fourth loop is at the back. So this is how the D orbital goes. And finally we have the F orbital. Again the nucleus is there in the middle. And you have 1, 2, 3. 3 lobes in just one axis. 4, 5, 6, 7, 8, 9. Are you getting it? So this is how we have the S orbital shape, P orbital shape, D orbital shape, F orbital shape. S is the simplest one, then we have the P and D and the F get more complex than what they were before. So this is how it actually works. S, P, D, F, and so on are the names given to the orbitals. These orbitals have different shapes. Example, electron density distribution in space and energies. For example, 1s is lower than 2s, which is lower than 3s, and so on. What do we mean by this is 1s is lower than 2s. That means 1s energy is lower than the 2s energy. I have the nucleus over here in the middle, and after that I have the shells. This is the first shell. After that we have the second shell. So since the first shell is nearer to the nucleus and second shell is further away from the nucleus, the first shell has more effect of the nucleus. The nucleus has more attraction towards the first shell. And because of that, this particular first shell, 1s, will have lesser energy. As we keep on increasing the energy levels, that means from 1 we go to 2, we go to 3, and so on, the energy level will also increase. Why? Because as we move further and further away, the nucleus will not have a lot of effect on the various shells which are going ahead. Now let us see the example. A hydrogen atom with one electron will be denoted as 1s1. How 1s1? I have a hydrogen atom over here. This is the nucleus. And we have an electron over here. So now what do we do is, this particular electron is one electron in the first shell. So it becomes 1s1. It has one electron in the 1s orbital. In the same way, we have lithium with 3 electrons. Let us do it over here. Lithium, we have 3 electrons over here. So again, I'll just make the nucleus of lithium over here. And then in the first shell, maximum it can have 2 electrons. Why? Because 1s has the capacity of 2. So I'll have to make one more shell over here. And while I'm making one more shell over here, I'm making another electron. In the 2s orbital, I have 1 electron. Total 3 electrons. First 2 electron went in the 1s shell. The last electron went in the 2s shell. So what does it become? 1s2, 2s1. Correct? So this is how it is. 1s2, 2s1. Correct? Why? Because in the 1s you have 2 electrons. And in the 2s you have 1 electron. Similarly, for fluorine, you have 9 electrons. Fluorine has 9 electrons over here. So how will we do for fluorine? 9 electrons. So let us just make fluorine over here. Let me just erase out the hydrogen, and instead of hydrogen, we will make fluorine. Fluorine with 9 electrons. 1s2, 2s2. So this became 4. Now how many do we have remaining? 5 remaining. So it will become 2p5. So this becomes 1s2, 2s2, 2p5. Over here, I'll just write a 2. So this becomes 5 plus 2, 7 plus 2, 9. Total of 9 electrons for fluorine. Again, as we read from left to right, the energy of the orbitals increases and the superscript shows the number of electrons in the orbital. By SPDF configuration, he meant orbital configuration. So we start off with a principal quantum number, and principal quantum number is nothing but the number of shells as we discussed before. And why do we have different kinds of quantum numbers? So if I have a nucleus in the middle, and if I have the orbitals which are surrounding the nucleus, and inside the orbitals I have different electrons. So these particular electrons need to be classified and need to be found out. We need to find out where this particular electron is going to be. It is like human beings living in a city. If you are living in a city, and if you are living in a particular locality, and you tell us that you are living in this particular locality, we will have a higher probability of finding you in that particular locality. In the same way, when we're talking about electrons and we know that they are in a particular orbital, that is the point when we will be able to find them easily. The probability of finding the electrons is easier when they are in a orbital. There are lots of electrons in an atom. Now, if we want to distinguish between those electrons, then we need to name them, or there should be something to distinguish them. Imagine you are living in a circular state and the cities are named as the radius it has. So what will we have? We have sector 1 for one city. That means it is in the first radius. So the sector 1 will be this thing. Sector 2 will be this thing. Sector 3 will be the thing after that, and so on. By principal quantum number, we actually mean the probability of finding that electron is high within that particular radius. And thus, n, the principal quantum number, is nothing but the number of shells, which is 1, 2, 3, and so on. So for example, if I have my nucleus over here, the principal quantum number for this orbital will be 1. For this particular orbital, my principal quantum number will be 2. For the next orbital, my principal quantum number would be 3, and so on. After the principal quantum number, we have the azimuthal quantum number. This is like the building that you live in. Once you know that particular sector that you live in, so for example, this is the nucleus, this is the orbital. After that, what we need to find out is the building in which we live in. So now if you are living in a city that has very small and it has only one building, then you need not specify that particular building. If this particular area has only one building, if it has only one building, you do not have to name it. People will understand that this is the building wherein you live. For example, for n equals to 1, L is equals to 0. For the first principal quantum number, azimuthal quantum number is 0. So if n equals 1, my L is equal to 0. Correct? So here azimuthal quantum number or the building number. But if n is equals to 3, then we will have L is equals to 0 to n minus 1. So now how do I get that? Let me write the generalized version of it. If my n is equals to 3, then my n will be 0 to n minus 1. So what all will I get over here? What is my n over here? 3. So this will be 0 to 3 minus 1, which is equals to 0 to, what is 3 minus 1? 2. So I have 0, 1, and 2. This becomes my azimuthal quantum number. So this is the important generalized version of the relation between the principal quantum number and the azimuthal quantum number. If n is equals to 3, L will be 0 to n minus 1. And finally, we have the magnetic quantum number. This is like the apartment number of the building. So M is 0 to plus or minus 1 times L. So if you are living in building number 3, you can have 3 minus 2 minus 1, 0, 1, 2, 3. That means if this is your L, this is your L, you will have to get the positive and the negative versions for L to get the values of L. So what is 0? There is no positive or negative 0. You have positive 1, positive 2. You will also have negative 1, negative 2. So this becomes my values for M. This is the major formulation or the relation between M and N. This particular thing over here is N. M is 0 to plus or minus L, all the values of L. At the end, we have the spin quantum number. Each apartment has 2 rooms. It can be room A and room B. So over here, why do we have spin quantum number? We have done spin quantum number in the previous video as well. Every electron has equal and opposite force. It can be a positive force which is merged with a negative force. So it will be over here positive and this will be negative. So this is actually unrestricted Hadley-Fock case. But if you're living with spouse, then you can live in a large room. So this can also be in like one orbital.
Now the building name can be rephrased as S, P, D and F.
over here we have s, p, d and f with us. Now why do we have s, p, d and f with us? Because s orbital, p orbital, d orbital and f orbital, three are the four orbitals around us. So if you are living in a building number, let's say the number is 0, that means you're living in the s orbital. So now building number 1 is p, building number 2 is d, building number 3 is f. So in your building 0, now what was building 0? Building 0 is s orbital. From where did we get there? We got it from your number 0 is s orbital. So if I have building 0, which is the s orbital, the total number of rooms in an apartment can be, one apartment has 2 rooms. And 2 rooms means 2 electrons. In the same way, when I talk about building number 1, so how will we do it? 3 apartments into 2 rooms. So 3 twos are 6. So the second one will have 6 electrons. The S has 2 electrons, P has 6 electrons, and D has 10 electrons, and finally F has 14 electrons. So it is 1s2. After that we can have 2s2, 2p6, 3s2, 3p6, then 4s2, and after that what I can write over here is 3d10. And of course, finally, when we'll move on further, we'll have 5f, 6x, and 7f, and they will have 14 electrons. So 2, 6, 10, and 14. These are the numbers. So now if we want to know more about it, we can have a look at Hund's rule, Pauli's exclusion principle, and Aufbau principle. But they are all superficial theory. They can say what is going on, but they cannot say why. And we have to understand each and every electron and why it is happening. But quantum chemistry method will give you a mathematical understanding of why there are 2 rooms. That means basically 2 apartments, 2 rooms which have a particular set of electrons. We are having a metaphor of rooms and apartments for orbitals, orbits and electrons. It's a fact that each shell itself is composed of subshells, and experiments have showed how different subshells look. We have already seen the S, P, D, and F. We have already seen the orbits. This was S. Then we had a dumbbell ship P. This was P. And then eventually we had D and F as well. And D and F orbitals are a little difficult to portray in 2D because they are complex 3D configurations. The number of subshell each shell has depends on the number of shells. For example, the first shell, the second shell, wherein the first and second quantum number, the principal quantum number, is 1 and 2. The subshells are known as S, P, D or F. S subshell can fit 2 electrons, P can fit 6 electrons, D can fit 10 electrons, and F can fit 14 electrons. We have already done this. I'll write it one more time. S can have 2 electrons, P can have 6 electrons, D can have 10 electrons, and F can have 14 electrons inside that particular orbital. The first shell has only s orbital, so it is called as 1s. Whereas after that you have 2s, 2p, 3s, 3p, 3d. They are also known as SPDF configurations respectively. We have hydrogen, helium, and with them we start off with it. In this way, you would consider electronic configuration of oxygen to be 1s2, 2s2. Over here, you can see it is 1s2, 2s2, 2p4. So how will I write it properly? I can write it as 1s2, 2s2, 2p4. Another important point to note is that the filling of electrons in the subshell doesn't actually fill from low to high. It can fill in the way they want. It will generally fill from low to high, but it actually happens by half filling and then full filling. And that is given to us by Aufbau's principle on how the filling of it is entirely done. The German word for building up is Aufbau. I'll just show the diametrical representation of Aufbau. I've already shown this to you in terms of how the electrons were being filled. So we have 1s2. After that, you have 2s2, 2p6, 3s2, 3p6. Now, can you see after this there's an arrow going down over here? That means it will not fill 3D. It will first fill 4s2, then it will go to 3d10, then 4p6. And then after 4p6, what happens is, because there's an arrow going down over here, 5s2 will be filled first, and then 4d10. After that, we have 5p6, then 6s2. Then it will go to 4f14, 5d10, 6p6, and so on. This is the Aufbau's principle. You cannot just fill it in any way. This gets filled in this particular format. This, in fact, is the actual way of writing an electronic configuration. School teaches us the configuration per shell, but this is the actual way. The Aufbau's principle is the actual way of giving us the SPDF configuration. So in this way, we have completed the electronic configuration, how different electrons get filled in different shells, and how these shells come together and make the entire electronic configuration, including various electrons in the atom. Thank you so much for watching this video. Thank you.